Hi students, now in this video we will discuss about the conductors and the non-conductors. Right? Conductors are those substances which allow the current to flow through them, like we have a copper, iron. These metals, if you apply the electrode potential here, the current will flow through these substances. However, if you take the substances like the wood, plastic bag, plastic or the glass or the rubber, right, the things like these, even if you apply a very high potential difference, these substances do not allow the current to pass through them. So that's why we call them as non-conductors. So the conductors are the substances which allow the current to flow through them, while as non-conductors are the substances which do not allow the current to pass through them. Okay, and non-conductors we also call them as insulators. Okay, so the conductors can further be classified into the metallic conductors and electrolytes. Metallic conductors are the conductors like iron, like copper, right, these metals that we find, iron or gold or silver, these are something we call them as metallic conductors, because when current passes through them, there is actually no chemical change going on, right, during that process. So there is no chemical reaction which can occur in a metallic conductor, right. So they conducted the electricity without any kind of a chemical change during the process. Okay. However, the substances like the NaCl solution, right, or the molten NaCl or any salt solution, right, like suppose we can say the sodium chloride solution or like the potassium bromide, the substances like these, when you take these substances in the aqueous solution or in the molten form, they conduct electricity, but when the current passes through them, okay, there is some chemical reaction which is going on, right. So basically the substances decompose into their constituent particles. So that means the electrolytes are the substances which allow the current to pass through them in aqueous or in the molten state only, and not in the solid state. If you take NaCl here, and this NaCl is a bad conductor actually when it is in the solid state, but if you take it in the aqueous solution or in the molten state, it allows the current through them, right. So the current passes through them, and with the result also the NaCl, the sodium chloride, decomposes into the sodium and chlorine gas. So if you take the suppose NaCl molten form and you pass the current through it, you will get the sodium and the chlorine. So that means through electrolytes current passes, but at the same time a chemical reaction occurs in the substance. A chemical reaction we know is it's not a reverse, it's an irreversible thing, right. So once you pass the current through the electrolytes, you get the new substances like the sodium and the chlorine. As I said, that these are the substances which conduct electricity only in the aqueous solution or in the molten state, right, and not in the solid form. In the solid form they act as insulators, the non-conductors, because in the solid form the ions present in the sodium chloride or any other electrolyte, the ions are very strongly held together, and even when you apply a very high potential difference, the ions cannot move. So that's why the electrolytes in the solid state are bad conductors, right, while as in the aqueous solution or in the molten form the ions are a little bit free and they can move, right. Suppose let's take an example of here a molten NaCl. Okay, if we have a molten sodium chloride, and if I apply a potential difference here across this solution, what I find, the sodium moves towards this electrode and the chloride in this direction. So these are the two ions which move in the opposite directions, and the reaction which occur over here, suppose at the anode, what will happen here, the Cl negative, it loses electron, undergoes oxidation, because this is an anode and we know anode is the electrode where oxidation occurs, so it forms the chlorine and an electron. Now then, two chloride ions, they can form two chlorine atoms can combine and form the chlorine gas, and what you can expect here is the chlorine gas, Cl2 gas at the anode, plus electrons. The electrons, they start flowing through this one, and now at this electrode the sodium ion will gain the electron and form the sodium metal. So you get a metal here at this particular electrode. Now the current which is produced here due to the movement of the ions through the solution, we call that as a electrolytic conductance, right? So this is an electrolytic conductance. So electrolytic conductance is basically the current produced due to the movement of the ions, due to the flow of the ions through the solution. Now these electrolytes, we further classify them into two categories: strong electrolytes and the weak electrolytes. Strong electrolyte is the one which dissociates completely, like NaCl, okay, potassium chloride, or the strong acids like HCl. If you take NaCl here in the aqueous solution, right, so what you get the sodium ions and the chloride ions. Now if you take suppose HCl, again it will dissociate into H plus and Cl negative when dissolved in the aqueous medium. So strong electrolytes dissociate completely in the aqueous solution to give the ions. So that's why these are called as strong. While as the weak electrolytes, they dissociate partially. There is an equilibrium, right? There is an equilibrium, like the acetic acid. Suppose if you take the acetic acid CH3COH in aqueous medium, okay, when we take the water as a solvent, there is an equilibrium between it is dissociated form. This is the CH3CO negative here, the H plus ion that will react with the water and form the H3O plus. So but there is an equilibrium, you do not get 100%, the acetic acid in this example does not get 100% dissociate, right? So there is a partial dissociation of the weak electrolyte. So obviously when you look at the weak electrolytes, the number of ions will be less, okay, from the weak electrolytes, while as the number of ions in the strong electrolytes is high. So if the number of ions is high, so we can say the electrolytic conductance for the strong electrolytes will be high than the weak electrolytes. So strong electrolytes conduct electricity more than the weak electrolytes, because in the strong electrolytes we find more number of ions due to the complete dissociation of a strong electrolyte. So if you take suppose 1 gram of NaCl, and you will find that you will get if you take the 1 mole of NaCl, you will find 1 mole of sodium ions, 1 mole of chloride ions. Total number of ions will be 2 moles. So that will be completely dissociated. However, if you take a weak electrolyte, it dissociated partially, not 100%. This dissociation is there, right? So partial dissociation, which means number of ions which are the current carrying ions, these will be less, and so therefore the electrolytic conductance for the weak electrolytes is less than the strong electrolytes. Hope you got the concept. Thanks for watching the video. Bye for now.